Thank you, Stephanie. We met with these growers and others in these three stakeholder areas to review the technical team's findings and discuss how current and future cropland groundwater demand could be met with various recharge strategies. We use these meetings to identify local cropping, water management, and recharge preferences and how they differ across the SACOG region. This map highlights those three best areas for recharge that the earlier technical analysis revealed. This map shows that the three areas also include both non-specialty cropland, shown in pink, and specialty cropland, shown in purple or blue. All three areas have a good mix of both types of land, which will affect future scenarios. We held actually 4 stakeholder meetings, one each in one in Marysville representing Yuba, Sutter, and Placer counties, one in Sacramento representing the South Sacramento County region, and 2 meetings in the Woodland area representing Yolo County. For each region, we invited water managers from irrigation districts and county government, along with agricultural leaders and ag advisors, including the Farm Bureau, Cooperative Extension, and ag commissioners, as well as local nonprofit resource management professionals. This was not an in-depth study, but a ground truthing to assess local interests and concerns about groundwater supply and recharge opportunities identified in the technical work previously shown. This is the framework we used for seeking stakeholder input and advice after first presenting the technical findings from the study. We wanted to know what future water and cropping conditions would look like in these 3 examples, with continued water management, with no new managed aquifer recharge, that's the baseline water use scenario, under SGMA implementation, where pumping restrictions might be required to achieve groundwater sustainability, but assuming current levels of natural and managed aquifer recharge. And then in the third set of questions and discussion was around potential recharge options that could be considered or were being considered locally to maximize available surface water capture. And this included not only recharge on specialty cropland versus non-specialty cropland, but also cropland versus non-cropland recharge options, as well as a variety of different non-cropland recharge projects and permitting challenges associated with these different types. Here's just a few examples of these recharge options that came up during the discussions. We encouraged consideration for a variety of options, including recharge on active, especially cropland, such as the grape image in the upper left here, but also recharge on non-crop ground along floodplains, as shown in the upper right, or use of fallow, non-specialty cropland in the lower left, or dedicated recharge basins or old gravel pits as other forms of non-farm recharge. So now I'm going to, for each region, show you what we learned about current groundwater conditions and recharge activities. Beginning in the Yuba, Sutter, Placer region, we learned that stakeholders made it quite clear that recharge is not a big priority because of high water tables and little capacity to capture more surface water. In western Placer, however, there are areas of groundwater depletion due to new orchards and other water use demands where recharge would be beneficial. When we started talking about recharge potential, it was clear that local groundwater agencies are interested in developing groundwater banking programs where possible to store water when abundant and sell these waters at later times. This would be a departure from the current strategy of selling surplus water to other regions when it's available that many of the irrigation districts currently practice. So not a strong, great interest in recharge based on the fact that there's not a lot of need in the majority of the area. Looking at the agricultural land use in this particular portion, zoomed in a bit more from the previous slides, notice the amount of rice ground shown in light green. Recharge is naturally occurring on this land, albeit at slow rates due to clay layers. But this, along with natural river bottom recharge, is what is maintaining groundwater at a fairly high level in this region. Orchard ground showed in red and orange in the Sutter and Yuba areas to the north and to the west sees fluctuations in groundwater levels during droughts and floods, but it's mostly stable. The western placer area in the lower right, where expansion in orchards and urban water demand is resulting in new groundwater demand and diminished groundwater levels, and where recharge potential is to be the greatest. This map shows where irrigation districts exist within this region on top of the good suitability category of recharge land. So this drastically shrinks the area where recharge can be conducted, and it shows also that there are some recharge opportunities outside of irrigation district boundaries that were not considered due to the cost of building new surface water conveyance to reach these areas, such as the Sutter Buttes in the northwest portion of Sutter County. Not all areas within irrigation districts necessarily have adequate conveyance for recharge either. Again, the light green in this map shows rice, with red and orange being tree crop areas that are located on good suitability soils and geology, and where recharge potential could be the greatest. Also viewing this just from the specialty, non-specialty crop division, we can see how much land has the potential to be converted should the value of specialty crops continue to rise, driving the conversion and planting of new orchards. The pink are the non-specialty cropland that could be used for recharge if they're fallowed. But much of this is already in rice and is having recharge benefits. The dark blue is the current specialty crop ground that is suitable for recharge now. So if we see a lot of the areas of non-specialty crops converted, we will see a loss of short-term quick recharge and a conversion to specialty crops that can still be recharged but might be at a slower rate. Turning now to South Sacramento County, overdraft is much more of an issue. There's currently very little active recharge except at a few pilot study sites. Vineyards provide an excellent opportunity in this region for recharge due to their crop compatibility mentioned previously, and the potential for expansion of recharge in the area unfortunately is limited by the lack of surface water diversions or conveyance, despite the fact that water can be plentiful during wet years off the Cosumnes River and the American River to the north. Stakeholders expressed much interest in obtaining contract water through the Folsom South Canal off the American River, which would utilize an existing conveyance canal to deliver water to local streams as far south as the Cosumnes River, and could be used to recharge in old gravel pits alongside the canal to benefit the entire region. The interest in recharge in this area is high among farmers and water managers, but will require funding and incentives to expand the conveyance out onto the lands that are suited for recharge. These funds could be generated through groundwater sustainability agencies if the stakeholders see the value of achieving increased recharge rather than having to reduce water demand. So look at this visually. Here's the land use in the southern portion of Sacramento County with the dark purple color representing grapes, not the darkest, but the more maroon color being the grapes, extensive acreages of that, both in the Cosumnes River drainage as well as down in the Galt Irrigation District on the southern boundaries of the county. Those grape acres represent good recharge compatibility, as do the orchard crops indicated in the reds and orange colors. But there's a lot less of those acres in that area. When we look at where recharge suitability is good, it's more limited, and unfortunately Galt does not have adequate conveyance capacity to reach all these locations. And the areas along the Cosumnes River are also drastically shrunk when we look at good locations. So diversion off the river is a possibility for those fields that are highlighted here along the light blue of the river. And finally, again, looking at this in terms of specialty and non-specialty crops, it appears that in the Galt region to the south, there's still a lot of non-specialty annual cropland that exists in that area, and conversion of these lands to permanent crops will again reduce the potential rate of recharge at any given site, although grapes still provide significant recharge potential. So conversion to grapes will not significantly reduce the potential for recharge in this region if water can be moved to those sites. And then finally, in Yolo County, groundwater conditions have been improving as urban areas have obtained supplemental surface water from the Sacramento River and Yolo bypass. The cones of depressions that existed there are being corrected, and water availability for recharge on the west side of the valley, however, is more time constrained than the other two study areas. This is because a lack of snow melt and snow storage means that water is mostly available in a shorter time span between January to early March. So more recharge capacity is needed to capture water in a short period for recharge. The Yolo Flood Control and Water Conservation District has an active recharge program using their unlined irrigation canals off Cache Creek and is encouraging on-farm recharge. Other non-crop recharge opportunities exist to use dry creek beds and sloughs to divert excess water into those for natural recharge. However, in this area, as more land goes into permanent crops, the demand for groundwater will increase and has been increasing in some areas and will need to be met with more surface water capture for recharge. The current cost of regulatory permitting was cited as a major barrier to expanded recharge due to the cost of obtaining permits from the State Water Board as well as from state and federal projects. Looking at the crop distribution in the Yolo County region, we can see that there's extensive agricultural production ground throughout the region, but only the areas served by the Yolo Flood Control and Water Conservation District in the western portion have access to surface water from Cache Creek and Colusa Canal systems. Even less of this farmland is suited to good recharge infiltration, unfortunately. This map shows the areas that fall under the best category of recharge suitability, and the boundary of the Yolo water providing area is shown in the line I'm highlighting here, which shows that a lot of the acreage is actually outside of the district's delivery region, which limits the areas where recharge can occur. The map shows the suitability of good recharge along the route of Cache Creek coming out of the Coast Range from the west, and its deposit of coarse-grained sands and gravel out into the valley. This map only shows the best-rated lands for recharge, but there are more good-rated lands within the district boundaries that could be served by existing canals, and although they might not recharge as quickly, should also be considered by the stakeholders, one of them to be considered as additional supplemental recharge areas to the north and south of the Cache Creek corridor. There are also a number of idle fields shown on the best recharge land, indicated here in the tan color. These fields are fallowed during droughts and also offer great recharge during wet years. Fallow fields offer the quickest recharge sites since they can be flooded when water is available without concern for crop health. Oftentimes, many inches of water per day be infiltrated on these lands, whereas cropland with crops on them, there's more restrictive rates of application due to concerns about crop health. However, if these fallow lands are converted to permanent crops, that will impact the rate of water application that can be conducted in Yolo County during the short periods of time that water is available. In summary, for these three regions, there are opportunities to greatly expand recharge, and interest is growing in areas where groundwater supply is at risk. Expansion of specialty crops and associated hardening of water demand will force even more attention to recharge in the Sigma era. New water demand for high-value crops will come into conflict with maintaining sustainable groundwater supplies, especially during drought periods. And permanent crop producers will need to assess whether they are willing to do recharge on their valuable crops or engage their GSAs to encourage recharge on fallow or annual non-specialty crop ground where the risks are lower and ability to capture water quickly is higher.